Hello, and welcome again to FlippedHarber for Precalculus. In this video, we'll be covering Section 1.2, Solving Equations. Our objectives for this lesson are to use the basic math operations to solve equations. Use a root to find the solution of equation. Find the solution of an absolute value equation. And solve quadratic equations by both factoring and using the quadratic formula. Our topics for this lesson are basically solving equations. This whole video will be a series of examples. So let's start with a nice linear equation, 6 minus x equals 2x plus 9. All we need to do is combine like terms by moving the x over and moving the 9 over. We get negative 3 equals 3x. Now divide by the 3, we get x equals negative 1. Here's a quadratic equation. I know it's quadratic because if everything is multiplied together, we'll end up with an x squared term in the equation. That x squared term is the defining characteristic of a quadratic equation. Now you may be thinking, let's go ahead and multiply the left side of the equation and the right side of the equation. But that's actually not what we're going to do in this one. Because this quadratic equation is actually already factored out, we can approach it a little bit differently. We generally want to try to solve quadratic equations by factoring. So if it's already factored out, try to avoid losing those factors. We'll move everything to one side of the equation, so we have two terms separated by a minus sign. Our first term is x minus 3 squared. Our second term is x plus 2 times x minus 3. Both terms have an x minus 3 term, so we factor that out. The first term is left with x minus 3. The second term is left with x plus 2. Simplifying inside the brackets, we have a negative 5. If we divide that over, we're left with x minus 3 equals 0, or x equals 3. So there's our answer, and we box it in. Here's an equation with a couple fractions in it. One great way to get rid of those fractions is to multiply by the common denominator. In this case, that common denominator is an x plus 2. Now when you're doing this, don't forget that you're multiplying the entire equation. Whether we need to get rid of that denominator or not, we're multiplying it by the x plus 2. So the first term just turns into a 3x. The second term just turns into the negative 6 on top of the fraction. But that third term gets a lot bigger. We get a minus 2x minus 4 when we distribute in the negative 2. Now we'll just combine like terms and solve for the x. We get x equals negative 2. But wait a minute. We can't plug in a negative 2 because it would give us 0 on the bottom of a fraction. Since our only solution can't be plugged back in, we have no real solutions. That's what we box in on our paper. Let's take a look at an absolute value equation. Now the way we accomplish these is we take the absolute value equaling some number and we break it up into two separate equations. In both cases, it's just the stuff inside the absolute value, and we set it equal to a positive and a negative 6, because the absolute value of negative 6 and the absolute value of 6 are both 6. So now we have two small equations that we solve simultaneously. Dividing by 2, we get x equals negative 3 and x equals 3. Now both of these solutions will work if we plug them in. They're both correct, so we box them in together. Here's another absolute value equation. Big difference here is we've got something outside the absolute value. We have to deal with that before we break up the equation into two smaller equations. So I'll get rid of the 3/4 by multiplying by 4/3. Absolute value of x equals 12. Now we break it up into two small equations, x equals negative 12, x equals 12. So here are our two solutions, and we box them in together. Here's an absolute value equation that doesn't have the variable inside the absolute value. Since the variable isn't in there, we can just deal with it. The absolute value of negative 2 is 2. So we get 2x equals 4. X equals 2 is our only solution. Alright, here's another quadratic equation, but this one is not factored out. We'll move all the terms to one side of the equation so that we get x squared plus 2x minus 15 equals 0. you should always try to factor quadratics first. This one will factor into x plus 5 times x minus 3. Set both factors equal to 0 and solve for them. We get x equals negative 5 or x equals 3. Box them in together. Here's another equation with x plus 2 as a denominator. We're going to get rid of those denominators again by multiplying by x plus 2 throughout. Remember, no matter what, x cannot equal negative 2. Basically, we get the top of one fraction equals the top of the other fraction. You need to resist the urge to cancel the x plus 3's. If you cancel them, you'll actually lose an answer. So we go ahead and multiply out the left side. We get x squared plus 2x minus 3 equals x plus 3. Combine like terms, and now we'll factor. We get x plus 3 equals 0, or x minus 2 equals 0. That means that x equals negative 3, or x equals 2. Now neither one of these actually breaks the rule that x cannot equal negative 2, so they're both good answers. Here's another quadratic. Again, let's get everything to one side of the equation so that it all equals 0. This one will not factor, so we're going to have to approach this quite a bit differently. We'll use the quadratic equation. Remember, your a value is in front of the x squared term, your b value is in front of the x term. In this case, don't forget that negative goes with it, so our b value is negative 3, and our c value is the constant at the end. In this case, a negative 18. We plug it all in, and we start to simplify. Under the square root, we have 9 plus 144. So that's 153. That's what we refer to as our discriminant. Now, 153 is not a perfect square, so that means that this square root will not totally go away. But there is a factor of 153 that is a perfect square, 9. So that 9 can come out of the square root and become a 3. So our final answer is 3 plus or minus 3 square root of 17 all over 4. This actually represents two solutions because of the plus and minus. Here's another equation that has fractions. I need to multiply by something that will get rid of all of the fractions. So I'm actually going to multiply by x squared minus 4. Because x plus 2 is a factor of x squared minus 4, that one multiplication will get rid of all three denominators. Remember, we cannot have x equals plus or minus 2. When we multiply, we're going to get 2x equals 4 minus x minus 2. It's the part that didn't cancel when we multiplied that third fraction by x squared minus 4. We'll go ahead, distribute the minus, combine terms, we get x equals 2. Would that break a rule? Yes, it would, so there's no real solutions. Okay, so here's our homework for this section. I hope you wrote everything down, because all of these examples would be great questions on our next notebook quiz. We're all set. I'll see you in class, and I'll see you in the videos.